So hi and what's up everybody. In our today's video I am going to show us how to create a very interesting IoT project using Raspberry Pi and Microsoft Azure services. So the learning outcomes of this video is by the end of this video you should be able to create an IoT hub, you should be able to create stream analytics, you should be able to create a storage container in Azure Cloud, you should be able to program Raspberry Pi and send of course this data on Azure, and the last objective, which is very interesting, you should be able to visualize this data on Azure. We will start by using Azure CLI and of course go into other advanced services. Now, where we start is by understanding this architecture. So this is a simple more of flow architecture, and this is the diagram which shows how data flows. So we are utilizing Raspberry Pi. You can use any Raspberry Pi as long as it can support MQTT protocol. And we are using a sensor source data, which can be any sensor of your choice. For this, actually, we are going to use DHT sensor, and we are utilizing this protocol called MQTT. MQTT stands for Message Queuing Telemetry Transport Protocol, and this protocols allows you to send telemetry data from your device to cloud. Our cloud of choice is Azure Cloud. So we are going to use some very specific resources on Azure Cloud. I mentioned this because you find and realize that Azure has got a lot of resources, has got thousands of resources, and we are utilizing some few resources which relate to IoT. So our first resource that we are going to use is IoT Hub. If you're new to IoT Hub is actually fully managed and helps you connect your devices, monitor, and of course manage billions of IoT devices. That's on Azure Cloud. So one very key feature about IoT Hub, it support what is called D2C and C2D. That means cloud to device and device to cloud communication. And another big feature about IoT Hub is it has the capability of connecting to so many resources. The output from IoT Hub are so many. And for this particular video, we'll be exploring Stream Analytics. Stream Analytics is a resource that allows you to stream real-time data from your device, from your IoT Hub to an output. Maybe if you want to store it, we will be using blob storage. If you want to draw more advanced insight, you can use Power BI. If you want to manipulate your data more, you can use what is called Azure Functions. This icon is for Azure Functions. You can also get your data through Event Grid for more advanced operations of your data. You can get your data through something called machine learning. That is if you want to maybe more of do some anomaly detection of your data. You can get your data from Stream Analytics through something called SQL or SQL database. You can also get your data from Stream Analytics to something called Cosmos DB. This is Cosmos DB. So without much ado, I want to take us to Azure Marketplace. So if you do not have an account, a Microsoft Azure account, you can always Google creating a new Azure account. It's very straightforward, and Microsoft Learn has always given a lot of information on how to create this account. So if you follow this, if you're a student, even better, there is a student version of an account. You can create that. If you're not also a student, you can as well create a free account, which you can, you are given a lot of credits which you can use for practicing and exercising these amazing, interesting projects. So this is how Azure portal or marketplace looks like. If you have created previous project, you will notice that on Azure portal you will have your projects on Azure portal, like I am having these and many more of my projects. And what you do is always click create a resource. So our first thing that we want to create is what is called IoT Hub. IoT Hub is here, and the next thing we want to the first thing we create is IoT Hub. So search IoT Hub. After searching IoT Hub, the next thing you do is click create. So there are a number of IoT Hub services which shouldn't confuse you. This is IoT Hub device provisioning service, IoT Hub itself, IoT Hub, IoT Eng metrics collector, Tata Bit, IoT Bridge. But what we want to create is first IoT Hub. So you click IoT Hub, click create. I presume that you do not have a resource group. So there is something called resource group, maybe a new terminology to someone out there. A resource group, if you hover around these icons, you notice that they explain what these are. But in layman's language, a resource group is more of a main folder for all related files or all related project files together. You put them together in more of a container. So, and by definition, they are saying a resource group is a collection of all resources that share the same life cycle, permissions, and policies. Yeah. So you click create one. If you don't have one, you can call it maybe Pi resource. The tick means it's correct naming. Then click OK. The next thing you do is your hub name, maybe Pi Hub 1, Pi Hub 100, Pi 1, Pi Hub 100 is there. For the tier, please just choose free tier. This is to make sure that you are not billed. And the next thing you do is just click review and create. So you notice some kind of account. You cannot create more than one IoT hub. So for me, I already have a IoT hub, so this one it will not allow me to create free IoT hubs are limited to one per subscription. So if I end to create another one and maybe to choose basic, and let's see this. So just click review and create. So after clicking review and create, it takes very few minutes to create the IoT hub. So for you, please make sure that you have chosen free tier or free tier. This to make sure that you are not billed a lot of money every now and then. So you click create. So I will create this just to show you how it's done. So it shows initializing deployment. After you are done creating your resource or your IoT hub, it will deploy. And once the deployment is done, you can navigate to your IoT hub. All right. So it's still deploying. Okay. So after you are done deploying, the next thing you do is you can click go to resource, or you can navigate to home page again. And if you try refreshing, you will find that all your resources will appear here. No new notifications. So it should have been done. The next thing you do is, let's say this is your hub, whatever the name you called it. So you click on it, click on your IoT hub name. After clicking on the IoT hub name, you realize one thing. On the left hand side, we have a number of tabs you can navigate around. More of the overview of IoT hub. So for instance, this IoT hub that I have been having, it has sent it is having 3 devices connected. It's of 3 free tier. That means can send up to 8,000 messages in a day. And for the 3 devices, it is showing them here. So it's up to 3 devices. The next thing is all of this is summary. So what we want to do is now create a device on our IoT hub. So the device that we will be creating on IoT Hub, just click navigate to device management and click devices. After clicking devices, the next thing you do is navigate into this place here and click add device. So for your case, you might find that you do not have any device because simply you did not have previous devices created. So for me, this IoT Hub has up to 3 devices. So click add device. After clicking add device, you call it whatever the name you want, maybe Hub, Pi Hub, whatever the name you wanna call it. Just give it reasonable name. So by having a tick here means it's a allowed name or its correct name. Then click save. After clicking save, um, it doesn't take much time. Created a device and its name is Pi Hub 1000. Then refresh. This is Pi Hub 100. So if we open this Pi Hub 1000, sorry, you notice one thing. We have connection string. This is more of what is used to connect your device to cloud, to Azure Cloud. So it has 3 main properties. That is the host name. The host name is usually the hub name or the IoT hub name. The device ID, that is the ID that you have named your device, and shared access key. This is the shared access key,
which is used for authenticating your device.
so the next thing we do now that we already have an IoT hub is you copy this primary connection string, and after copying the connection string you paste it some place, say in Notepad. Paste it in Notepad. The next thing you do is navigate to home page. After navigating again to home page, that is marketplace, Azure marketplace, I want us to create another resource, storage. We saying that I'll be showing us how to store this data. So we want to create a storage resource, search storage. After searching storage, the next thing we do is we create a storage account. So here it is. A storage account contains more of, you can store your data on storage account. Storage name it. Maybe you can call it Pi storage 100. The field can contain only lowercase. Pi storage, I want to call it Pi storage 100, and everything else leave it as it is. But for redundancy, I want us choose locally redundant storage. It has the lowest cost, so I want us choose this. The next thing you do is review, and after review you should be able to click create. So but it's not active. Oh, it's now active, so click create. So after you click create, it takes few minutes to deploy again. So it is submitting deployment. Okay, and as it is submitting deployment, I want us create our next resource by the name of stream analytics. Notice that the process is we'll be getting our data from Raspberry Pi through this protocol MQTT to IoT Hub. We have already created an IoT Hub, and through IoT Hub, and we have already created our container, and now we want to create stream analytics. So it takes few minutes to finish deployment. So it's done. Navigate to home and create the next resource called search for stream analytics. After you search for stream analytics, please don't confuse with these jobs. Just click stream analytics and click create. You leave everything default apart from the name of your stream analytics. So for the resource group, remember we created a resource group called Pi resource. So select Pi resource. For the name, you can call it whatever the name, Pi stream 100, to associate or rather to relate all your projects or all your resources with 100 stream units. Again, put it to 1. So the next thing you do is click review and create. After that, as long as you have copied your connection string, I want us to go to Raspberry Pi. Now make our hands dirty. So I'm using Raspberry Pi 3 as I said, and here is my VNC um, viewer. So let me open it. Password is rasp. Click enter. I made an error. Let's see. So it's successfully logged into my Raspberry Pi. Click the terminal. Let's navigate along and create our file ls. Much of does list all the folders and items in the main directory. And if you are very new to these commands, I have a beginner's course in Udemy. I'll be more of making it official, and I will share all of those videos with you guys. You can more of use them and get started to understand the basics of Raspberry Pi. Change directory to desktop. Where we list, I want us to create another directory. Make directory. Call it can call it new Pi 2023 list. So we have created this directory, new Pi 2023, and change directory to new Pi 2023. And I want us to create a .py file nano. I want us to create a .py file nano pi humidity.py. Click enter, and boom, you're good to go. So let me get back just a little bit. So the first thing you need to do is, even before I go on to coding, there are some things that you need to do. So the first thing you have to do is make sure that your Raspberry Pi is installed with Python 3 or Python 2. And here you can see we have Python 2.7. Let's see if we have Python 3 here, the version. As you can see, we have version 3.7 of Python. That's why even if you try to do something here, print hello, it's able to print. So we have the right Python in this Pi. If you do not have the right Python, you can always do sudo pip3 install python 3, and it will install, or sudo pip3 updates python 3. And there are some other few dependent packages related to Azure that I want you or us to install. So the first one, you will do sudo pip3 install Azure IoT device. After installing that independent dependent package, the next one you install is this package sudo pip3 install Azure IoT Hub. So you need to install this Azure IoT Hub package. After installing that second package, the next one you do is sudo pip3 install Azure IoT Hub service client. my window is small, but after dash client, press enter. It shouldn't take a few minutes to install that. Install the fourth dependent package, sudo pip3, install azure dash iot dash IoT Hub dash device dash client. So one thing you notice is if you are doing this video as of 2023, is the last two, which is IoT Hub service client and IoT Hub device client, have got some errors. So not worry, even if you get errors, we will be using the first two, that is um, IoT, that is Azure IoT Hub and Azure IoT device, to communicate to Azure IoT. So if you missed this, it's sudo pip3 install Azure dash IoT dash device. The second one is sudo pip3 install Azure dash IoT dash device dash, should be dash hub. If you get lucky, you can try these last two, sudo pip3 install Azure dash IoT hub dash service dash client. The fourth one should be sudo install Azure dash IoT hub. There's a mistake here. This should be IoT hub dash the first one is service, the second is device dash client. I want now to show you the code, and more of, we can either do live coding or I can share the code on the comments. But to save on time and to make sure that this video is not too long, I will show you the explanation of the code. So this is the code, and the first thing we are doing is we want to import these important libraries. Random is not important, so we are importing all the, let me use vital libraries. So we are using DHT 22. So for this case, I'm using the Underfruit library. So another thing, please remember to install Underfruit library. And for you to install Underfruit library, it's very simple. I forgot to show you that. All you need to do is just sudo python setup dot py install. This command, press enter. This command does install the it installs the Underfruit library. So it's sudo python setup dot py install install, and this, what it does, it installs the DHT library package from Underfruit. Okay, so now the next thing we are going to do, I hope you are enjoying this so far, and the next thing we are going to do is, I was explaining the code to you. We are not going to write it out, but I'm going to explain it to you. So this is my editor. I'm using this favorite editor that almost everyone uses, and we are importing the vital library files. This is Underfruit DHT, and we are importing time. We'll be using it mainly for interval, for message interval, let's say for sending of message interval. The next thing is we are importing this library. We are importing IoT Hub device client and message from azure.iot.device. We are defining the pin that we will be using for our DHT. So please note that if you are using DHT11, you have to specify at this point. So for me, I'm using DHT22, and that is what is happening here. And the pin that I'm using is GPIO. This is GPIO. This is GPIO pin 4, which on SoC or system on chip, it's pin number 8. To be specific, let me show you in Raspberry Pi itself. You can just type pinout, press enter. Okay, so I'm using GPIO number 4. This is pin number 7 or GPIO number 4. So if you can be able to count from 1, 2, 3, 4, it's pin number 7, which is GPIO number 4. So I think I made an error here. So it's number 7 on system on chip. So the next thing you do is we want to define the connection string. Please make sure that you have replaced this with your connection string. Do not use my connection string. If you use my connection string, then it will not connect. So here, replace with your connection string. Replace with your connection string. The thing is, as you remember, I said that this connection string is a property of three things. Number one, the host name, which carries more of the, if I can say, it carries the hub name, that is the IoT hub name. IoT hub name. The second thing is device ID, and the third thing is shared access key. Shared access key. So what you do is we copied it here. So you copy it or you cut and replace it inside here. All I'm avoiding is I don't want someone to use my connection string, but all you do is replace it in this place. We are defining an array which will be storing this data. So our array is in form of, we have temperature and humidity. So two parameters, temperature and humidity. And on while loop, we are using this library called underfruit to read our data. And this data is being stored in these two variables, which is humidity and temperature, which are our array, which we have already defined up here. So the next thing we do here is use a function to connect our Pi or to our connection string. So this function here is what we are using to connect our Raspberry Pi to the cloud using our connection string. What is our connection string? Our connection string is which you already pasted here, so it's already predefined in this place. At this point is use a function which is defined here to send this data on Azure Cloud. So you realize one thing I didn't here is I am using try and except. This is to catch any possible errors. And in case, of course, your sensor is fault or in case you connect your sensor wrongly, you realize that you will always see some error exemptions in your code. So essentially, this function here is used to send your data to Azure Cloud. So that is it. And time.sleep here, these are in terms of seconds. So it means that you are using up to 10 seconds to send this data. You can define in whatever time you want your code, sorry, to send your data. So maybe 3 seconds, 1 minute, whatever the definition you want. So after you understand this code fully, now you are allowed to either copy and paste it in in your Raspberry Pi code editor, or you can directly type it as I've been explaining. This is my Raspberry Pi, and let me clear. So where am I? Let's list. So inside my directory, I am having this Pi ham. So let me change directory and return back to my Pi, to my next directory.
So this is the connection circuit diagram, VCC to VCC, ground to ground, and of course the signal to GPIO number 4.
Clear again, list. Let me run PyCap C Python 3 humidity temperature. Let me run this. Same code, same concept I have explained. Okay, now here are my parameters. So the temperature, as you can see, is 26 and the humidity is 66. So I want to show you how exactly you can now visualize this data on Azure CLI. So what you do, the next thing you do is refresh your Azure um, Azure portal or Azure Marketplace. And if you click on your IoT Hub overview, you realize one thing. The messages are increasing from the previous number. So for instance, on my Raspberry Pi here, I am sending messages at a frequency of, let me see, maybe I shouldn't change this. Nano, um, let me change the frequency of sending messages. I want to use, I'm sending these messages after a long time, after 1 minute. Maybe for you to see what I mean, I want to send the messages after every 5 seconds. Control or enter to X, and then Python 3, you mean temperature, enter. So this sends after every 3 seconds. So you realize that on the overview, these messages should be increasing. So we have 20 messages sent today. Let's see if it will send more messages after now sending 3 messages after every 3 minutes, every 3 seconds, sorry. um, so we have 21 messages. That means it's receiving messages. Very interesting. So as you can see, it is sending 3 messages, a message after every 3 seconds. This is a lot. We'll be utilizing a lot of messages. Maybe let interrupt, control send. Maybe we shouldn't be sending messages after every, maybe say, what do you think? Send messages after how many minutes, how many seconds? uh Maybe somebody says, um let it sleep, let it send after every 30 seconds. 30 seconds makes sense. Control enter, control X, then Python 3 you mean temperature, then click enter. Okay, so let's see this magic. And now we are in the MQTT thing. It is the MQTT thing happening. So our humidity is 65, temperature is 26, and let's see if the messages are increasing in our platform. And and yes, oh yeah, they're increasing. So we have up to 4 messages. So now the next thing I want to do is now show you how you can visualize this data using CLI. Specifies the IoT hub name and device name. So it's, let me write the name here. It goes by AZ IoT Hub Monitor. It is a predefined command event, spacebar, use hub dash name. This is where you have your hub name. This is IoT hub name, and let me remove this because it's not there. This is where you have IoT hub name. The next one is we specify dash dash the device ID, the device ID, and your device ID. Okay, now where do you find this? My device ID, copy yours. If you copy mine, you notice that you will not get any data. So my device ID, there's one here, is real time. So IoT hub name, my IoT hub name is hub 1230. Okay, device ID, my device ID is real Pi 002. So you copy this and paste it on your CLI. Paste it on CLI. Remove this. Um, Remove that, and that. Is the IoT hub, event hub name. That's my name, device ID. It is real time Pi 002. Click enter. So what we expect is real time data. So it's more of filtering the device written on my IoT hub. So wow, it's finally here. So as you can see, this is 26.799.69.6999, and it's the real-time data being sent on cloud. The next thing we want to do, guys, is to get this data from IoT Hub to now the next stage that we talked about, getting the data from IoT Hub through Stream Analytics to a storage and to other places, the likes of Power BI, Azure Functions, Event Grid, machine learning. And now, um, what we do is just minimize this. This will keep sending data. We need to more of stop this. Well, let now go to our dashboard. Remember, we created a Stream Analytics. So the next thing you do is click on Stream Analytics. After clicking on Stream Analytics, we want to configure an input and an output to our Stream Analytics. So in the Stream Analytics job, you notice there are two things. Number one, we have an input and an output. So to configure our input will be coming from IoT Hub, and our output will be a storage container. For this case, we are going to use blob storage. All right. So you click input. To avoid any confusion, I'm also going to delete this input, and also in my output, I am going to delete it. All right. I'm going to delete it. Okay. Now, I remembered something. We didn't create a storage account. We didn't create a specific storage container inside our storage account. So our storage account was this one here, realtime 001, the one that you created. But remember, for me, I already had it. It's not a sense of creating more, but you remember the process of creating one. So click on your storage account or storage resource. After clicking the storage resource, you realize that there's something called container, and in the container is whereby you can create different resources. So on this container, I want us to create a container. Click create, and the next thing you do is name your container. This one we are going to call it container 002 and public access level. This is more of, it will specify whether this data can be accessed either publicly or privately. So for now, let's keep it private and click create. After clicking create, the next thing you do is navigate. So we have our container here by the name container 002. So this is where we want to output our data into. Again, do not lose the track. We have our input into stream analytics being IoT Hub, and our output for now being blob storage, which is a container inside our storage resource. So I'm going to home and click your stream analytics. After clicking your stream analytics allows you to stream real-time data from an input source to an output. All right. Okay. So what we want to do is configure an input or ingest data. So ingesting data is more of consume and input data. So click input. I want to delete this. I don't want any confusion to come to any one of you. Okay, I hope it's no longer there. Yeah, it's no longer there. So I want to add input data, and the input will be from IoT Hub. So click IoT Hub. The alias name can be input 002, input hub 002. We provide from storage. So IoT Hub name is this, blah blah blah. Here I want us to provide JSON. Want is in JSON format, and the next thing is everything else default. Don't think there is anything you have to change here. Everything just default as it is. Click save. Takes few minutes to save. The next thing we do is configure or hand. You can test your input. So let us test our input. So our device is still sending some real-time data. So connection tested successfully. Let's test our output. So let's configure our output. So our output should be to a storage container which we have been creating. So remember, this data can be piped to anywhere. All of these output, as I was explaining to us in this picture, that you can pipe this data to either Azure functions, Cosmos DB, SQL database, machine learning for anomaly detection and other analytics, event grid, Power BI, blob storage. It has so many output here, service bus topic. But for today, I want to show you how exactly you can store this data. In the next projects, I'll be showing you how you can as well visualize this real-time data on Power BI. Something you note about Power BI, you need an organization email. But if you are a student again, you can use your Azure student account subscription to visualize and analyze this data on Power BI. All right. So for now, I want us store this data on blob storage. So click blob storage. After clicking blob storage, you want to call it output blob 002. Okay, output blob 002. Keep everything else default. For container, I want us choose the container name, call it blob 002, and I want us to use existing, and oops, if we use no container available, no containers are available. So if no containers are available, I don't know why exactly it is not showing, but if no are available, you can always create one. So just click create one. And the next thing we do is leave everything default. Path, this is what I want us define just date, and by using this kind of just define date, have the date format that you want, and we are going to go click save. So it is ending the output, and then successfully let's test our output. Testing the output. So successfully done. No. The output, yes, it's done successfully. Output blob, yes, it's done testing the output. So after you are done testing the output, the next thing you do is go to overview, and I want us to do something to start our stream analytics job. Or first we can do what is called testing query. So just click test query. Test query gives you more of overview of defining the input and output. Okay, testing query comes after you have configured your output and input. So this data goes to output blob 002. It's here. So this output blob 002. The data is from input hub 002. That is our IoT hub. And let's test query. Already, even before we test query, as you can see, the data is guys flowing here like no man's business. So this is real-time data. As you can see, it's flowing here, and that is input data. Let's test the output data to be sure that this data is going to the right storage. So this data, as you can see, it is going into our output storage. So our data is still being sent by our Pi. So remember, this is real-time data. So the next thing I want to do is check if this data is being received in our container. And to make sure that it will be received in our container, I will start my stream analytics job. To start my stream analytics job means that I'll allow the input data from IoT Hub to my stream analytics to be stored in my container, which happens to be my blob storage. So this takes few seconds. Most of the time you find that stream analytics fails to start the job, but it doesn't matter. We have to make it work. I hope so far you are enjoying, guys. Remember, if you are able to complete these projects, you have understood very many resources, IoT resources on Azure. I know there are so many courses in Udemy, in Coursera, especially in guided courses, which covers this concept. And we have covered much more concept than what is even covered in those courses. So takes few time to start stream analytics jobs, and after starting stream analytics job, all we want to do is make sure, of course, our data from the input is being received in the output. And as you remember, we have tested the query and we are seeing that our real-time data from Raspberry Pi here, and we have sent up to a 19 we have sent a number of data points so far. As you have seen, it's being received. This is real-time data is being received in our cloud platform. Beautiful. So it has started the stream analytics job successfully. So let's see where our data is stored. So this is our stream analytics job, which is running. And let's see the output that we chose. So our output is called output blob 002, and the resource is this one here. So if you click it, you notice that of course we are storing it in blob storage. So you can click blob storage or also containers. And inside the container, we have our storage resource, which is blob 002. Inside the blob 002, you notice that we have subfolders. And if you can delete, like if you can download this data, you will notice that it's in form of JSON format. Open. So guys, this is very impressive. This is our data, our real-time data that we have been sending in JSON format. And my next video, I am going to show you how you can visualize this data and of course use other more advanced Azure IoT resources. And thank you so very much for staying tuned. Please remember to like, subscribe, and share this channel with your colleagues. Thank you so much.